Welcome to my next lecture on database management systems, which is on the higher normal forms. We have till now covered the second normal form, third normal form and the Boyce Codd normal form. All these three normal forms, they were based on the concept of functional dependencies, or which we call as the FDs, right. Now, the two higher normal forms that we will study, that is the fourth normal form and the fifth normal form, they are based on the concept of the multivalued dependency, that is the fourth normal form is based on multivalued dependencies and the fifth normal form is based on the project join dependency. Now, let us see why we need to have the normal forms higher than the Boyce Codd normal form. We have already seen that the Boyce Codd normal form, it is sufficient for solving any problem of repeated or redundant information. That is, when we did the BCNF, we saw that BCNF normalization or decomposition leaves the decomposed relations into a form which do not have any redundant information. The problem is attributed mainly to one attribute being the multivalued attribute. I am writing here. Why? Because in some cases we may have more than one attribute being a multivalued attribute. When we had started in the beginning with the relational design, if you remember, I told you that if we have a single multivalued attribute in a relation, then the problem of redundancy can be solved by having a separate relation for that multivalued attribute. But in case if there is more than one attribute in the relation which is having multivalued, then in that case we may suffer the problem of repetition or redundancy, and such a problem or such a constraint is specified by multivalued dependencies, and it requires the fourth normal form, decomposition. Now, let us see through an example what a multivalued dependency is. Look at this data. This is not a relation. Why? Because any cell cannot have more than one value. So, this is not a relation. I am just showing you some data, which means that Kumar has two projects. So, that means a multivalued attribute project, and department, he has two departments, again department is a multivalued attribute, right. Rao, three projects, again a multivalued attribute, that means project is a multivalued attribute, department is a multivalued attribute. So, here we are facing a situation where more than one attribute in this given relation is a multivalued attribute, and we may not be able to separate it into separate different relations. So, just for our future this thing, I will call this particular relation that we will form from here as the EPD relation, which is shown as this. What am I saying? Kumar has project P1, dependent D1, but at the same time I also have to say that Kumar has project P1 and dependent D2, right. So, that is what I have written over here. Even though the employees project and dependent are independent of each other, okay? Project and dependent, they are absolutely independent of each other, but we need to have a separate tuple to show each combination of the employees project and department. That is what we have done here. We need to have a separate tuple to show the information about each employee's project and department. A separate tuple to show Rao P1 D3, Rao P1 D4, a separate this thing to show. similarly over here, and so on. So, where is the redundancy now? Obviously, there is so much of redundancy that every time we say that there is a project, we repeat the value of the dependent. We keep repeating the value of the project, right. So, this is the kind of redundancy that we are facing here, and hence it is not a good database design, this particular relation, and may lead to update, insertion and deletion anomalies, which is not acceptable. Now, let us look at the definition of a multivalued dependency. Okay, next slide, sorry. In a relation schema R, an attribute y is said to be multi-dependent on the attribute x. So, how is a multivalued dependency written? Like this: if and only if for a particular value of x, the set of values of y is completely determined by the value of x and is independent of the value of z, where z is equal to r minus x union y, right. So, in our case, what do we have? Employee multi-determines project and employee multi-determines dependent. How? We are saying that employee multi-determines x union y, r minus x union y. What is left? In our case, dependent is left. This is what a multivalued dependency is, and to remove the redundancy that is there because of the multivalued dependencies, we need a higher form than the BCNF, because BCNF can eliminate redundancies only that are based on FDs. Thus, there is need to introduce the multivalued dependencies and the fourth normal form. Now, a multivalued dependency x determines y or multi determines y in a relation schema is said to be trivial if y is a subset of x or x union y is equal to the given relation. Now, in our case, what are the two multivalued dependencies? Employee to project and employee to dependent, right. Are they trivial functional multivalued dependencies? Y is a subset of x. In both the cases, the right hand side is not a subset of the left hand side. Okay. Second is x union y should be equal to r. Employee union project does not give you the original relation. Employee union dependent does not give you the original relation. So, both these multivalued dependencies, they are non-trivial multivalued dependencies, right. Now, we will need this in the fourth normal form, that is why we defined the trivial functional multivalued dependency. Okay. So, a relation schema R with respect to a set of dependencies F, which can be functional dependencies and multivalued dependencies, is said to be in the fourth normal form if every multivalued dependency of the form x multi determines y holding on R satisfies one of the condition that it is a trivial multivalued dependency or the left hand side is a super key, right. So, what did we have? We had employee multi determines project, employee multi determines dependent, and our relation was employee project dependent. Now, this if we look at it, look at the data over here. This what is the key for this relation? Employee is not a key, project is not a key, dependent is not a key, combination of any of these two is not a key. This is a all key relation what I have written over here. That means all the three attributes together will only form a all key relation, and when there is a all key relation, then in that case we always have a trivial multivalued or functional dependency. Why? Because when it is a all key relation, then obviously employee, project, departments multi determines. So, we have a trivial functional dependency. So, where were we? We were over here. We have this is a all key relation. Now, employee to project, multi determines project, it is not a trivial multi-value dependency. Why? Because employee is not a super key, this is not a super key in both the cases. Second condition for a trivial multi-value dependency was that x to y should be a y should be a subset of x, y is not a subset of x. We have already said these two are non-trivial. The second condition, x is a super key, not satisfied. So, this relation is not in 4NF. What is the next step we have to take up? The next step is that we have to decompose this relation into 4 normal form decompositions. Okay. So, what we will do is, let us say we decompose it into EP employee project with the multi-value dependency employee multi-determines project, and employee dependent with the multi-value dependency employee multi-determines department, right. Now, let us see over here that is this a trivial multi-value dependency in what? In EP? No, it is not a trivial multi-value dependency, because right hand side is not a subset of the left hand side, and also employee union, sorry, it is a trivial multi-valued dependency, because employee union project gives us the original relation. Similarly, over here this is a trivial multi-value dependency, because employee union dependent gives us the relation ED. Now, since both these multi-value dependencies are trivial multi-value dependencies, so the decomposition we have done over here is a (4NF) decomposition, right. Now, decomposition of a schema R based on the multi-valued dependency X multi-determines Y that holds on R into R1, which is X union Y, and R2, the original relation minus the right hand side, will give you a lossless joint decomposition. If you remember the decompositions in 2NF, 3NF and BCNF, this is how we were doing the decompositions over there also. The lossless joint property for 4NF is that R1 intersection R2 multi-determines R1 minus R2, R1 intersection R2 multi-determines R2 minus R1, then the decompositions should satisfy one of these two multi-valued dependencies. Now, this is another example, course, student name and textbook. We have the multi-valued dependencies, course multi-determines student name and course multi-determines textbook over here. Now, let us see whether this relation is in 4NF or not. The multi-value dependencies, they are non-trivial. Again, it is a all key relation you can look at from the data. So, that means the left hand side in any of the multivalued dependencies is not the key, and hence this relation is not in the fourth normal form. If I decompose this relation into these two relations, that is course student name and course textbook, course student name and course set textbook, then over here the multivalued dependency that we have is course textbook, and over here the multivalued dependency that we have is course student name, right. Now, over here, is this a trivial multivalued dependency? Yes, it is a trivial multivalued dependency. Why? X union Y is equal to the relation. This is also a trivial multivalued dependency because X union Y is the relation, and since here we have the trivial multivalued dependency, here we have the trivial multivalued dependency, which is the condition for the fourth normal form. Hence, this decomposition is in the fourth normal form. Now, let us look at this example. We are given the relation schema A, B, C, D, E, the set of functional dependencies here. We have to find the lossless joint decomposition into 4 and F. So, what are the conditions for 4 and F? That the functional dependencies should be trivial or the left hand side should be a key. Now, all these three functional dependencies, they are not trivial functional dependencies. We can see because both the conditions for the trivial functional dependency, that is either X union Y is equal to R, or the second condition that is there, the right hand side should be a subset of the left hand side. Both the conditions, they are not met, hence the functional dependencies are not trivial functional dependencies. So, that means we need to find the key for R. So, A closure is A, B, C, D, which is not equal to R, hence A is not a key. Similarly, from this functional dependency, B closure is B, C, D, not equal to R, hence again B is not a key. E closure is equal to A, D, E, which is equal to A, B, C, D, E. From where? From here, which is equal to R. So, the key for the given relation is E. Now, let us see the third functional dependency. It satisfies the fourth normal form, but the first two functional dependencies, they violate the fourth normal form. So, what we will do over here is that we will decompose this relation into two relations based either on A to B C or on B to C D, which violate our fourth normal form. So, decomposing on the basis of MVD A to B C, we get, what did we say? R is equal to R minus Y union X Y. So, R minus right hand side B C, that is A D E union X Y, that is A B C. So, this is the decomposition that we get. A D E and A B C. In ADE, the functional dependency that we have is E to AD from the original functional multivalued dependencies, and the multivalued dependency in ABC we have is A to BC from the original multivalued dependency. Now, over here we see E is the key, left hand side is the key, and hence we say that the relation ADE, it is in fourth normal form. Over here we see A to BC, A is the key, and hence the decomposition ABC is also in the fourth normal form. So, the 4NF decomposition is ADE with the MVD E to AD and the key E, ABC with the MVD A to BC and A as the key. So, this is how we can perform the decomposition into fourth normal form. Now, next we have, like I told you, the joint dependency and the fifth normal form. Till now what we have been doing, we have a relation R. If the R does not meet the criteria for a particular normal form, what is the decomposition process? We decompose into two relations R1 and R2. Okay. So, in case now R1 satisfies the normal form we are looking for, it is okay. Maybe R2 still does not satisfy the normal form we are looking for. We may further decompose it into R3 and R4 and so on. So, that means that every time we are performing a decomposition, it is a binary decomposition. But there may exist relations that cannot be lossless decomposed into two projections or relations, but can be lossless decomposed into more than two projections, right. And these relations, they may be in 4 and F, they may be in BC and F, but still we will say that they are not in the right design. Such relations, they have another type of dependency which is called a joint dependency, and if a joint dependency is present, then we need to have a multi-way decomposition which is called the fifth normal form or the project join normal form. That means, a relation that has a joint dependency does not meet the fifth normal form and has to be decomposed into the fifth normal form. Now, look at this relation over here, right. If I decompose it into three relations P1, P2 and P3, this is what I get. And then if I perform a natural join of this P1, P2 and P3, I get this back. What have I done? Performed a natural join of P1 and P2, a natural join of P1 and P2, and whatever I get, a natural join of that with P3. So, this is what we get when we do a natural join of P1 and P2. This has a spurious tuple, but when we perform the natural join of this with P3, we get the original table. Thus, a joint dependency is said to exist because what did we say? A joint dependency means that when a relation can be decomposed into more than two projections and that decomposition is a lossless decomposition. So, obviously, here our decomposition of this relation into these three relations is a lossless decomposition, and hence we say that a joint dependency exists, right. A joint dependency which is denoted by this, that is natural join of the decompositions specified on a relation schema R, specifies a constraint on the state of R, and not the schema of R. We have to be very careful, or we should know that all the previous normal forms that we have done, they were based on the on the schema of the relation, or they were a constraint on the schema of the relation. But the dependency which is the joint dependency, it is a constraint on the state of the relation, that means the relation with the data, right. That is why we always say that it is difficult to identify a joint dependency, whereas the others can be easily seen, because the state of the database may change very frequently. The schema of the database does not change. The constraint states that every legal state R of R should have the non-additive joint decomposition into R1, R2, look at the small r, such that the join, the natural join of all these decompositions is the original relation. Joint dependency, like I just said, is a constraint on the state of the relation and not on the schema of the relation. Now, a joint dependency is said to be a trivial joint dependency if one of the decompositions is equal to R itself. So, here we had shown the decompositions P1, P2 and P3, any of the decompositions is not equal to R, and hence we say that the joint dependency, it is not a trivial joint dependency. The fifth normal form, it states that a relation schema is in 5NF, like I told you, also called the project join normal form with respect to a set of FDs, MVDs and joint dependencies if one of the two conditions holds. What are the two conditions? The joint dependency is a trivial joint dependency. Second, each projection of R forms a key. Each projection of R forms a key. In our example, we can see that there is the joint dependency which does not satisfy any of the conditions for 5NF, because the joint dependency we just saw is not a trivial joint dependency, right, because for a trivial joint dependency what do you need? That one of the decompositions should be equal to R. The second condition for fifth normal form is each projection or decomposition forms a super key. Each projection or decomposition does not form the super key of R because of this relation, which is agent company product. Why? Because this is again a all key relation. So, hence this given relation, it is not in the fifth normal form, but again it may be difficult to decompose a relation into the fifth normal form, because like I said that the fifth normal form and the joint dependency, they are based on the state of the relation and not on the schema of the relation. The state of the relation, it will change from time to time, and hence it may be difficult to identify the joint dependencies. This is another example, SNO, PNO, JNO. Again look at the data, the state of the relation, again a all key relation. If I have these three decompositions of it, is this in fifth normal form? Is this in fifth normal form? No, this is not in fifth normal form, because a natural join of all these three will give us the original relation back. So, not a trivial, we do not have a trivial joint dependency. Why? Because again like I said, a trivial means that one of the decompositions is equal to R, which is not the case over here. It is not in fifth normal form, because the joint dependency is not a trivial joint dependency, and also the second condition was each decomposition must form a super key. It is a all key relation. The decompositions, they do not form the super key. So, this relation again is not in the fifth normal form. Thank you.